Today's class, we are going to be looking at test of difference. And basically, when we say test of difference, it implies that we are specifically looking at test of mean difference. So the mean, which is usually our bone of contention, is looking at mean between groups or among groups. So specifically, when you are looking at test of difference between two groups, we use the t-test. But when it is more than two groups, we use the analysis of variance. However, today, specifically, we are going to look at an aspect of the t-test, because for a t-test, it is either you are using a one sample t-test, an independent sample t-test, or a paired sample t-test. And obviously, just like the name implies, one independent and paired. It shows how the groups are related or different from one another. But this example we have here, experimental group and control group, this is a score emanating from an experiment among 6 participants. The score for the experimental group, which implies that they are separate set of individuals. The control group are also separate set of individuals, shows that they are independent of one another. So by implication, when we want to find the difference, we are going to establish test of difference using independent sample t-test. Without much ado, the independent sample t-test formula, just like it is stated here, clearly shows that we need to find the mean of group 1, the mean of group 2, the standard deviation of group 1, the standard deviation of group 2, as well as the number of group 1 and the number of group 2. Let me sound a note of warning. This N1 and N2 usually may not be the same. When I say may not be the same, it implies that if you have, for example, this is 6, 6. If you have an experimental group, 7 participants, and your control group just 4, your N1 will be 7, and your N2 will be 4 in that case. But in this example, they are the same. But most times, people usually get confused when they are looking for N1 and N2, thinking they must be the same. There's no rule that says they must be the same. The only thing is that you are trying to find how the group are different or alike. So, without really wasting much of our time, let us just go straight to establishing what we really need before we compute whether there is difference or not. So that means we are going to look for mean 1, mean 2, standard deviation of 1, and standard deviation of 2. By formula, the mean formula simply is the average. So without wasting much time, the mean of 1 will be summation of x1, that's all the raw scores for experimental group. We have already said this is our x1 and this is our x2. While the mean of group 2 will be summation of all the s2s divided by n. So we have 17 plus 14 plus 16 plus 9 plus 11 plus 14 all over 6. And we also have 7 plus 7 plus 6 plus 3 plus 5 plus 2 divided by 6. So specifically, when we have 17 plus 14, that will give us 33, 49, 58, 69. 69 plus 14 will give us 69 plus 14. That will be 69 plus 10 is 79. 79 plus 4 will then give 83. So we have 83. We have 83, meaning 83 over what? Over 6. Similarly, for the second one, we have 7 plus 7, 14, plus 6, 20, plus 3, 23, plus 5, 28, plus 2, 30. And that will be 30 over 6. By implication, our mean 2 is 5. 30 divided by 6. Why? For the first one here, it is 81 rather than 83. So 81 divided by 6 will give us 13.5. 13.5. So in the formula now, we have been able to solve the numerator. No, that means the numerator is already done. It remains the denominator. But in this denominator, we also know the value of our n1 and our n2 already to be 6, 6 respectively. So that implies that we are now concerned about the standard deviation of what? Of group 1, which is the experimental group, and group 2, which is the control group. So to find our standard deviation, thank God we have computed the mean too, because for you to be able to find your standard deviation, the mean is critical or important. We are going to look at deviation from mean. What do I call it? I call it deviation from mean because you call it standard deviation. But before you can get the standard deviation, you need the deviation from mean. The formula for computing standard deviation by formula, is standard deviation by formula is x minus mean all over what? N minus 1, then square root. So standard deviation by formula, I am putting square roots just because at the end of the day, the square root will cancel one another, if I am not mistaken. So it implies that mean deviation from the mean square divided by this, then you find the square root. When you find the square root, it becomes variance. But when you square it, that means when there is no square root, is what? Standard deviation. So get that right. So once there is no square root there, it is standard deviation. But when there is square root in the formula, it becomes variance. But we are not concerned about variance here. So the deviation from the mean, the sum of the deviation from the mean divided by n minus 1 will give us our what? Standard deviation. So that implies that with our mean for 1 is 13 points. So for this one now, we have x1 and x2. But let us do it one after the other. x1, we have x1 minus mean. If our x1 is 17, 14, 16, 9, 11, and 14 respectively, then our mean is 13.5. That implies that it's going to read 17 minus 13.5, 14 minus 13.5, 16 minus 13.5, 9 minus 13.5, 11 minus 13.5, 14 minus 13.5. We want to see how the mean varies, how each of the raw data varies from the mean. For the purpose of clarity, we will take them one after the other, so you can compute that also. 17 minus 13.5 will give you what? That will give you what? 3.5. However, just because of the square that we have there, it is important that we square it at a go, one after the other, because statistics is always stepwise. So 3.5 square will give you what? 12.25. That will take you step by step. If you wait till the end, you are going to be making double effort. By after writing the figure, you will now be squaring it again. It's better you just punch square at a go and write it out. So 14 minus 13.5 is going to be 0.5. Then square. 0.5 square will be what? 0.25. 16 minus 13.5 will be what? Then square. 6.25. 9 minus 13.5. You have to take note of the negative sign. That will give you minus 4.5. And the essence of you squaring is also to eliminate the minus. So minus 4.5 square will then give you what? 20.25. 11 minus 13.5 is obviously minus 2.5. Minus 2.5 will then give you 0.62. 6.25. And lastly, our 14 minus 13.5, just like what we have here, is 0.5. Then the square will be 0.25. We are almost done in our computation. Just like the formula has stated, summation. So it implies that you have to find the sum of all this that you have done. So let us sum it all together. 12.25 plus 0.25 plus 6.25 plus 20.25 plus 6.25 again, as well as plus 0.25. The total will give you what? 45.25. 45.5. And this 45.5, it shows that even in the standard deviation, you already have 45.5. And your n is what? Your n is 6. So your n is 6. So that means your standard deviation will be 45.5 divided by what? 45.5 divided by what? 6. 45.5 divided by 6, and that will give you what? 7.58. And more importantly, let you know this. It is important for us to know that when we already find our standard deviation for either of the two groups, it is important that you also do this for the other group. And for the sake of clarity, you are going to follow the same procedure. However, without wasting much time, just like somebody should help me confirm if this is the formula for your standard deviation or variance, which is correct. Because for standard deviation is square root of your variance. So that implies that we have only gotten our standard deviation to be 7.58. Our variance will now be our variance will be 7.5. Our standard deviation will now be square root of, because obviously when you solve, that's why practice is important. Something will tell you that something is not right at some point. So it implies that we are still not done here until we find the square root. So our square root of 7.58 would be what? 2.7 what? 2.75. So by now you are supposed to be able to replicate for the second one without wasting much time. So let us just do that once and for all, and we then compute. So for the second one, we have 7, we have 7, 6, we have 3, we have 5, and we have 2. And our mean is what? 5. So we have 7 minus 5, 6 minus 5, 3 minus 5, 5 minus 5, then 2 minus 5. 7 minus 5 is 2. So 2 square will give you 4. Similarly for this, 6 minus 5 is 1. 1 square will also give you 1. 3 minus 5 is minus 2. Minus 2 square will give you 4. Take note. That negative sign will be eliminated. 5 minus 5 is 0. 0 square will also give you 0. Then 2 minus 5 is minus 3. Minus 3 square will give you 9. So let us now sum this. That will give us summation of this. 4 plus 4 is 8, plus 1, 9, plus 4, 13. 13 plus 0 is 13. While 13 plus 9 will give you 20, 22. So that implies that for the second group, we have also been able to compute this value. And remember, one important thing that we also missed out is that if this is 22, then it implies that square root of 22 over what? What's your end? 6. Somebody should have asked that in some situation it will be n minus 1. In some other situation it will be simply n. When your data sample is large enough, it's better you do n minus 1 to reduce error. But because we are working with 6 samples here, so we can still go by n. But if you are also used to the computer system, it's the n minus 1 that is computed usually, because on computing, when you are using software to compute, it depends on large data. So it will first of all find the degree of freedom of the sample to also help you reduce inherent errors. So take note of that. I am sure sometimes that can be confusing. So 22 divided by 6 obviously will be what?
3.67.
And then square root of 3.67 will be square root of 3.67 will be what? 1.9. So we are able to get our, having been able to establish our mean deviation for experimental group, the summation of our mean deviation, which is 45.5, as well as mean deviation for control group, which is our x2, the summation of which is 22. We will then go back to the formula. The formula is saying for our standard deviation, the formula says summation what? Of mean deviation divided by n minus 1 squared. So going by that, you just have to put everything for the first one, which is our x1. We have 45 over our n is what? 6. 1, 2, 3, 4, 5, 6. Our n is 6. So that will be 6 minus what? 45.5 divided by 6 minus 1. Obviously, in some situation, they will say n. In another situation, they will say n minus 1. But usually, in computing, it is the n minus 1 value that is better, so that it will help us reduce error. So 45.5 divided by 5. The square root of 45.5 divided by 5 will be what? 45.5 divided by 5 will be what? 9.1. Then the square root of 9.1 will give us 3.0. So our standard deviation for experimental group 1 is 3.0. Now for experimental group, for control group rather, which is x2. Similarly, we have the formula, then we have our summation to be 22. So in this case, we have 22 divided by 6 minus 1. And that will be square root of 22 divided by 5. 22 divided by 5 will give you what? 22 divided by 5 will give you 7.4. 4.4. And square root of 4.4 is what? 2.0. That should be 2.0 something. 2.09, because it cannot be exactly 2.0. So this one that is 3.02 should be 3.0 something. Cannot be exactly 3.0, because 3.0 is 9. So it should be 3.0 what? 3.01. So by implication, our standard deviation for experiment for control group is 2.09, while for the experimental group is 3.01. So going back to the formula, that implies that we have to substitute the value. So the formula states for independent sample t test, the formula says t equals to mean 1 minus mean 2 all over square root of standard deviation of 1 square over n1 plus standard deviation of 2 square over n2. So mean 1 is our mean of 1 is what? 13.5. Our mean 2 is what?
6.
Our mean 2 is 6 all over. Take note that our standard deviation square. So if our value is 3.01, it implies that we have 3.01 square all over. Our n1 is 6. If our value is 2.09, it implies that we have 2.09 square. Our value still remains 6. Take note of that. 13.5 minus 5, because our mean of 2 is 5. So let us also deal with the numerator first. 13.5 minus 5 will give us 8.5. We have this in bracket, 3.01 square. The funniest thing is that when you square it, you are going to get 9.1. Am I right? 9.1 divided by 6 plus, when you square these two, you will get 4.4. 4.4 divided by what? Divided by 6. Once you are able to get that, we are going to deal with the denominator now, one after the other, because we are already done with the numerator. So we have our t to be 8.5. 9.1 divided by 6 will give you 1.5 what? 1.51. 4.4 divided by 6 will give you 0.73. Now let us sum it together. 1.51 plus 0.73. 2.24. The square root of 2.24 will now be what? 1.49. Our t calculated will now be 8.5 divided by 1.49. And that will give us what? 5.70. Our t calculated. Now, if the question is saying there is no significant difference between the experimental and control group, and you are able to get your t calculated to be 5.70 rather, your degree of freedom will now be n1 plus n2 minus 2. n1 is 6, n2 is 6 minus 2. So that means your degree of freedom is 10. There is a way you go into your tabulated value to determine your t tabulated. If your level of significance that you are operating with is 0.05, you will check for the tabulated value and compare it with the calculated value so that you will know whether to accept or reject. And you have to be careful of committing type 1 error or type 2 error as the case may be. In our next video, we'll be talking about another test of mean difference, which is a paired sample t test. Watch out. Thank you.